Our star, the Sun, is a colossal nuclear furnace, pouring energy into space every moment of every day. Its core burns at millions of degrees, fusing hydrogen into helium and unleashing unimaginable power. This energy radiates outward, traveling across the vast emptiness of space, reaching our small blue planet. When those rays finally arrive, they bathe our world in light and heat, transforming the cold vacuum of space into a vibrant, living world. The sun's warmth is what makes Earth habitable, turning frozen rock into a planet teeming with life. This energy drives our weather, stirs the winds, and powers the water cycle. It nurtures ecosystems, allowing forests to flourish and oceans to teem with life. Every leaf, every blade of grass, every living thing owes its existence to the sun's relentless energy. Yet, within those golden rays lies a secret: the potential to power our civilization cleanly and sustainably. For centuries we've marveled at the sun's power, but only recently have we begun to truly harness it. Imagine the scale. Every second, the sun fuses millions of tons of hydrogen, releasing more energy than humanity uses in a year. The energy that reaches Earth in just 1 hour could power the entire world for a year, if only we could capture it all. For most of history, we've relied on the Earth for power, burning wood, coal, oil, and gas. But what if we could catch the light itself as plants do and harness it on an industrial scale? What if we could turn sunlight directly into electricity, fueling our cities and industries with the same energy that sustains life? This is the reality of solar power, a technology that lets us tap into the sun's generosity. Solar panels are now appearing on rooftops, in fields, and even in deserts, quietly converting sunlight into clean, renewable energy. We've built devices that intercept photons and turn their energy into electricity, forging a direct connection with our star. Each solar cell is a tiny marvel, capturing the sun's energy and transforming it into power we can use. In this journey, we'll explore how a single solar cell works, how it captures sunlight, sets electrons in motion, and creates a flow of electricity. We'll see how science and engineering have unlocked the secrets of the sun, and we'll discover how these building blocks, when combined, create vast power stations that can supply entire cities, all powered by sunlight, clean and abundant. It's a story of human innovation meeting cosmic abundance, a testament to our ability to dream, to invent, and to build a brighter future powered by the greatest gift in our solar system. At the heart of every solar panel lies a remarkable phenomenon known as the photovoltaic effect, an elegant process that allows us to create electricity directly from sunlight. This effect is the invisible engine powering the solar revolution, quietly transforming the way we generate and use energy. The story of the photovoltaic effect begins in 1839, when a young French physicist named Edmond Becquerel first observed this curious effect in his father's laboratory. His discovery laid the foundation for all modern solar technology, opening the door to harnessing the sun's energy in ways previously unimaginable. Sunlight, which seems so ordinary, is actually made up of countless photons, tiny, energetic packets of light that travel across the vastness of space to reach Earth. Each photon carries a specific amount of energy, depending on its wavelength. When one of these photons collides with certain materials, like the silicon found in most solar cells, it can transfer its energy to an electron, knocking it loose from its atom and setting it free within the material. But simply freeing electrons isn't enough. To generate useful electricity, these electrons need to be guided, given a path to follow, so their movement can be harnessed as an electric current. That's where the clever design of solar cells comes in. Engineers build them with a built-in electric field, like a microscopic slope or ramp, that pushes the freed electrons in a specific direction, ensuring they flow in an organized way. This directed flow of electrons is what we call electric current. It's the same fundamental principle that powers everything from your smartphone to your refrigerator, but here, it's happening silently and directly from sunlight. The photovoltaic effect is a two-step marvel. First, sunlight liberates electrons from their atomic bonds, and then, the structure of the solar cell channels these electrons into a steady, usable current. The cell's internal structure acts like a traffic system, guiding the electrons along the right path so they can be collected and used to power our world. All of this happens quietly, invisibly, and at the atomic level. It's a direct, silent conversion of light into electricity. No moving parts, no noise, just pure energy transformation. While it may not be magic, there's something truly magical about the elegance and simplicity of this process. It's a testament to human ingenuity and our ability to unlock the secrets of nature. The photovoltaic effect is not only efficient and clean, but it's also deeply rooted in the strange and fascinating world of quantum physics, where the rules of the very small govern the flow of energy. Thanks to this effect, we can now plug our homes, our devices, and even entire cities directly into the sun, drawing power from a source that's both abundant and renewable. The photovoltaic effect is the spark that ignited the solar revolution, making it possible for us to rethink how we power our lives and our planet. It's the key that unlocks the sun's energy, turning sunlight into usable power for everyone, everywhere, and lighting the way toward a brighter, more sustainable future. The secret to a solar cell's power lies in silicon, one of the most abundant elements on Earth. Silicon is found in sand and rocks, but in a solar cell, it's transformed into a highly pure, crystalline form. This transformation is the first step in unlocking the energy of sunlight. But pure silicon alone isn't enough. To make it work as a solar cell, scientists use a process called doping, where they add tiny amounts of other elements to the silicon. This process is done in ultra-clean labs with extreme precision, because even the smallest impurity can affect performance. Pure silicon is stable, but by introducing these special elements, we create two distinct layers. One layer is engineered to have extra electrons. This is called the N-type layer, where N stands for negative charge. The other layer is made to have holes, or spaces where electrons are missing. This is the P-type layer, with P standing for positive charge. These two layers are the foundation of every solar cell. The N-type layer is created by adding phosphorus atoms, which have one more electron than silicon. These extra electrons are free to move, making the layer rich in negative charge carriers. The P-type layer, on the other hand, is made by adding boron. Boron has one less electron than silicon, creating holes that act as positive charge carriers, eager to accept electrons. When these two layers are placed together, something remarkable happens. Electrons from the N-type layer naturally move to fill the holes in the P-type layer, forming a very thin boundary called the p-n junction. This junction is only a few atoms thick, but it's where all the magic happens. The p-n junction creates a permanent electric field, acting like a one-way gate for electrons. This field is invisible, but it's always there, silently waiting for sunlight to arrive. When sunlight hits the cell, its energy knocks electrons loose from their atoms. The electric field at the p-n junction pushes these freed electrons in a single direction, forcing them to flow through an external circuit. This flow of electrons is what we call electricity. The p-n junction is the heart of the solar cell, silently directing the flow of electricity with every ray of sunlight. Without this tiny region, solar cells simply wouldn't work. This clever engineering turns simple silicon into a power generator, capable of lighting homes, powering cities, and fueling the future. It's a microscopic structure with a global impact, quietly working on rooftops, in fields, and across deserts to capture the sun's energy. The solar cell's design is a triumph of material science and human ingenuity, the result of decades of research and innovation. It's how we turn sunlight, a force that's been shining for billions of years, into a clean, renewable source of power for everyone. A single solar cell produces only a small amount of power. To be useful, many cells are connected together to form a solar panel. Cells are wired in series and parallel to achieve the desired voltage and current. The cells are sealed between layers of protective material, glass on the front, a waterproof backsheet, and a transparent encapsulant. The assembly is framed in aluminum for strength and easy mounting. On the back, a junction box gathers the electrical connections and includes safety diodes to keep power flowing even if part of the panel is shaded. This careful construction ensures panels last for decades, delivering reliable energy. A solar panel is a durable, engineered powerhouse, far more than just a collection of cells. Here's how sunlight becomes electricity. Sunlight passes through the panel's glass and strikes the N-type silicon layer. A photon with enough energy knocks an electron loose, creating an electron-hole pair. The electric field at the p-n junction separates them. Electrons go one way, holes the other. This separation creates a voltage, like a battery. Metal contacts collect the charges, and when you connect a device, electrons flow through the circuit, doing useful work. The process repeats as long as sunlight shines, producing direct current, DC electricity. It's a seamless conversion of light into power. Every solar cell is a tiny, silent generator. Solar panels produce direct current, DC, but our homes and the grid use alternating current, AC. An inverter converts DC from the panels into AC, matching the grid's voltage and frequency. The inverter is the system's brain, ensuring safe, seamless power for your home. It synchronizes with the grid, allowing you to use solar power or draw from the grid as needed. If you generate excess power, the inverter can send it back to the grid, earning you credits. At night or on cloudy days, the inverter switches to grid power automatically. The inverter is the vital bridge between solar panels and modern life. It makes solar energy practical and accessible. Solar energy's beauty is in its harmony with the environment. Unlike fossil fuels, solar panels generate electricity without emissions, noise, or moving parts. Manufacturing panels does use energy, but over their 25-30-year lifespan, they produce far more clean energy than it takes to make them. Solar panels use no water to generate power and reduce our reliance on finite resources. By harnessing the sun, we shift from extraction to abundance, building a sustainable future. Solar also decentralizes energy, empowering individuals and communities. It reduces the need for long transmission lines and puts power generation where it's needed. Choosing solar is choosing stewardship and sustainability. We've traveled from the sun's core to the heart of a solar cell, witnessing how a photon powers our world. Solar energy is a testament to human curiosity and innovation. The story is still being written, with new breakthroughs making solar more efficient and accessible. Understanding this technology connects us to the universe and inspires us to build a better future. If you enjoyed this journey, subscribe to Daily Magazine for more explorations into science and wonder. There's a universe of knowledge waiting. Let's keep exploring together. The adventure has only just begun.